Determine if the following set of vectors is a basis for R3. So to get us started here, we're going to let B be defined by the set of three vectors, vector B sub 1, vector B sub 2, vector B sub 3. And using these given vectors here, B sub 1 is 1, 0, minus 3. Vector B sub 2 we define as 3, 1, negative 4. And last but not least, we have negative 2, negative 1, 1. And so our job here is to determine if this index set of vectors is linearly independent, and if it's linearly independent, to show that it spans R3. So first things first, let's check if this set B is linearly independent. So in a previous example, we determined if the set was linearly independent by identifying that dependence relation. So you can do that with these three vectors here, but just for a little bit of variety here, let's use our foolproof method to check. We're going to take this set B and augment it with the 0 vector. So in other words, we have vector B sub 1, vector B sub 2, vector B sub 3, augmented with our 0 vector, and we want to make sure here that a free variable does not exist, confirming that this will be linearly independent. So we have 1, 0, negative 3, 3, 1, minus 4, and negative 2, minus 1, 1. And we want to row reduce this to echelon form. So taking my first pivot, I want to use it to eliminate the entry below. So we'll do 3 times the first row plus the third row to attain that new third row. And this gives us, see, the first 2 rows remain the same. I still have 1, 3, negative 2, 0, 1, minus 1. And then we have positive 3 minus 3 is 0. We have 9 minus 4 is 5. And last but not least, we have negative 6 plus 1 is negative 5. So our first column is good. Moving on to the second pivot, actually, we can reduce our third row here. We could do 1/5 multiplied by the third row to produce the equivalent matrix 1, 3, negative 2, 0, 1, minus 1, 0, 1, minus 1. And at this point, we can go ahead and stop. We can see that the third row is redundant. We could further reduce this and confirm to ourselves that a free variable certainly does exist if we combine R2 and R3, or minus R2 plus R3. We can see that we'll end up with 1, 3, negative 2, 0, 1, minus 1, 0, 0, 0. So while we can see that we have standard variables in the x sub 1 and x sub 2 position, we have a free variable here. So this lets us know that, therefore, this index set of vectors B is not linearly independent, which tells us that B is not a standard basis for R3. So as soon as we are able to confirm that this is not linearly independent, we can stop. We know if it's not linearly independent, then this set will not span R3, and therefore it is not a standard basis for R3.